on the screen, but a well-known underwater archaeologist that used to work in Wisconsin has written this great book. And so if you go, I'll post in the chat a link to where you can get the link for that meeting, but it's going to be an outstanding program on Great Lakes history from the perspective of shipwrecks. And it should be really interesting to everyone, and hope you'll be able to join us for that. Next month, our third Friday program is going to be a really interesting character. His name is Neil Zoss. He's written several books on whalebacks, and they are definitely the most unique vessel on the Great Lakes and something that's really distinctive to the Great Lakes. So we're going to have a program on the history of the Great Lake whalebacks. That'll be next month's third Friday. And then, so that's March, then April, we're going to have Daniel Gifford is a professor at the University of Louisville. And he wrote this book here, Last Voyage of the Whaling Bark Progress. It doesn't sound like something appropriate for Chicago, but you will be surprised. This is an incredible story about a ship. It was a whaling bark, obvious, but they filled it with all kinds of museum exhibits, and they sailed to Chicago for the 1893 Columbian Exposition. And things didn't go as they planned, and it turned into a really incredible story that's very much about Chicago, and I guarantee you, you will enjoy that one. So please be planning to come back and join us for those programs as well. I think we're ready to move on with tonight's program then. Oh, one thing, thank you very much to everyone who is a member. We really rely on our members and volunteers. If you're not currently a member, please consider joining, or if that's just not something you can do right now, any donation at all is greatly appreciated. If you go to chicagomaritimemuseum.org and click on, I think it's called the support button, and through that you can join or make a donation. Everything's greatly appreciated to help us keep operating and improving and making a better museum for all of us. So now I think we're ready for tonight's program. Richard Lanyon has been our only 3-time presenter in the past. Tonight, he becomes our only 4-time presenter. We're very lucky to have him. He started, he grew up in Chicago on the North Branch of the Chicago River and went to University of Illinois at Navy Pier. After that, he started his engineering career in water-related things and moved on to the Metropolitan Water Reclamation District, where he only worked there for 48 years. And the last 4.5 of those years was as the executive director. He retired in 2010. He's got a ton of really impressive awards. Please get his books and you'll see this list of awards. He was Civil Engineer of the Year in 1999 and a whole bunch of other really impressive ones. But after he retired in 2010, he started working on a huge collection of photographs that the Water Reclamation District has and started writing a series of 4 books. His first book was in 2011. It was called Building the Canal to Save Chicago. That was when we first met him at the museum, and fascinating story, really enjoyed it. I got all his books here. His second one came out in 2016. It's called Draining Chicago, the Early City and the North Area. After that, in 2018, West by Southwest, Draining the Central Area of Chicago and Exercising Clout. Very interesting stories in this one, as all of them have. And now, just last year, when we weren't able to host him last year for this, but really glad that he's here for our first virtual event. His newest and last of a series of 4 books is called Calumet First and Forever, Draining the South Area of Chicago and Territorial Expansion. So tonight you will learn why it's first and forever. Very interesting story. We are so happy to have him back again. So please welcome Richard Lanyon.
Thank you, Jim. That was a very generous introduction, and I am honored to be invited to be the first third Friday event after the recovery of the museum and while we're weathering out the pandemic. And thank you all for joining tonight. I hope you find this informative and entertaining. I think we're going to hold questions until the end, and you can pop questions into the chat room down at the bottom of your screen there, and we'll address those at the end. So with that, I'm going to share my screen, and we're going to get right into the program. And here we go. Aha. I hope you can all see that. A little bit of my screen is cut off on the right side with a few friendly faces, and I think the taskbar at the top will disappear if that's in your way. So we have a view here of Wolf Lake, and it's one of the remaining of originally 5 lakes in the Calumet area. And I start this book to talk about the drainage of the Calumet area because it's very complex and it's been massaged over the years. A lot of anthropogenic changes to the benefit of industry and navigation. And that's kind of the background of what the Water Reclamation District eventually did to address the pollution problems. This map, roughly around the turn of the century, over 100 years ago, shows the drainage in the area and a number of changes I'll point out. First of all, the Calumet River was not by nature connected to the Little Calumet, the Little Calumet and the Grand Calumet. Of course, these are modern day names. I think the Grand Calumet River came into being when they changed some of this drainage. But this connection was made sometime in the late 1800s, and there was all the marsh through here anyway. So this provided a new outlet for the Little Calumet River, and the resulting flow to the east kind of dried up. This also shows the Calumet Feeder that was built by the I&M Canal commissioners. A dam was built on the Little Calumet River here, Calumet River at this point near Blue Island. And by impounding about 10 feet of water, they could force the water to the west and through the Sag Valley to supply water to the I&M Canal. That lasted until about the 1870s. It was not beneficial for upstream landowners, and they eventually got the I&M Canal commissioners to take down the dam and restore the natural river flow. Many of the creeks from the west flowed through the Little Calumet River out towards Lake Michigan. And of course, here is Wolf Lake, we saw the picture of earlier, and George Lake, which is still there, but it's much reduced in size. At the west end of the Sag Valley, we see the other end of the Calumet Feeder that went north of the village of Worth around this Lanes Island, following the route of what is now Stony Creek, and it followed west and met up with the I&M Canal and a little settlement called Sag Bridge. Many of the tributary streams in the Sag Valley, some flowed to the west, and this area here was not connected, except it was all marshy, and maybe some of the water flowed east at that time. Meanwhile, over to the east in Indiana, we start near the state line, we see Lake George. There was another lake here called Lake Berry, and that was eliminated. Around the 1880s is when the Indiana Harbor Ship Canal was constructed, and when that was connected to the Grand Calumet River, that made another outlet directly to Lake Michigan, and of course the Grand Calumet River, which formerly flowed east and out into Lake Michigan by Miller, Indiana, began now to flow back and out through the Indiana Harbor Ship Canal. Another change that was made here is on the Little Calumet River, along the Calumet Beach Ridge, which is US Route 6, I believe. Hart Ditch was cut through the ridge and directly into the Little Calumet River. Otherwise, it ended up in a huge marsh that was formed behind the beach ridge. So we'll see that a little later in how that's impacted the drainage in the metropolitan area. So on after the first chapter, we talk about some of the work of the Water Reclamation District. And the first is the construction of the Calumet-Sag Channel. And the lower picture on the book cover is the old Blue Island Lock, which was the control structure on the canal just east of Blue Island. Here you see a pair of lock gates almost in the closed position. There's another pair up yonder at the east end. The picture above is the first Calumet water reclamation plant. It was built started in 1919 and was completed in 1922. And it was the first of the big plants that are still now operating. And of course, this first plant has been expanded and changed quite a bit over the years. And as we all know, Chicago was polluting Lake Michigan back in the 1800s. And in 1886, after the big August 1885 flood, dilution was thought to be the solution to pollution, and that's what came about with the idea of building the Sanitary and Ship Canal to reverse the flow of the river. And that eliminated, of course, one of the biggest sources of flow, of pollution to the lake. The city and the district cooperated in intercepting the sewers that were discharging to the lake by 1907. That ended that source of pollution. But as late as 1911, the Calumet River remained a growing threat because the area was developing later than the area of Chicago. Now, the sanitary district at the time wanted to approach the federal government and hopefully with Indiana's cooperation, to declare this as an interstate problem and get federal help to deal with the Calumet River pollution. However, Indiana was not cooperative. And on top of that, the federal government was opposed to reversing the flow of the Calumet River due to the belief that that would cause a drop in the level of the Great Lakes. And the pollution is shown here by this map. The Calumet River, of course, flowed into Lake Michigan by Calumet Harbor, right near the state line. And it was only 4 miles up to the water intake off of 68th Street. This was originally built by the town of Hyde Park. It was taken over by the city in 1889. And the 68th Street water pumping station supplied water to most of the south side of the city, everything south of 39th Street. So this was a serious threat to a large part of the population. The city had built a pumping station here at 95th Street that pumped all the sewage from the area directly into the Calumet River. And this is the city's pumping station. It went into service in 1907. By 1915, it had reached its capacity. It was a coal-fired steam electric plant, and it was replaced in 1925 by the sanitary district. So what was the plan to deal with this? Well, we knew by 1911 that dilution was not the solution. So reversing the river would not have helped much anyway, even if the feds did support it. What the district decided to do was build intercepting sewers to collect all the sewage, pumping stations to move the sewage away from the lake and the river, a plant to treat the sewage, and a canal to convey the treated effluent and as much stormwater as possible away from the lake. And of course, the channel that was built is the Calumet-Sag Channel, 16 miles in length through the Sag Valley, connecting to the Sanitary and Ship Canal over here near Lamont, and connecting to the Little Calumet River just east of Blue Island. in what is now Calumet Park. Besides Blue Island and Lamont, the only other town along this area was Worth, and it was a pretty remote area at the time. This was not like the corridor where the Sanitary and Ship Canal was built, which had 2 railroads and the Des Plaines River and other settlements. Looking from Archer Avenue to the east, in 1910, we saw what was the remnants of the Calumet Feeder. Here it was during the winter, kind of iced over probably, but by this time it had been unused for the I&M Canal, and it was filled with sediment and vegetation and debris and so forth. The middle part of the Sag Valley was these large marshes you see here. We're looking northeast along the old Wabash Railroad alignment. And I say the old one because this in 1911, this alignment was right down on the same level as the marshes, and the tracks could easily flood. The town of Worth is located on this higher land in the distance. And at the east end of the route, this is where the Stony Creek flowed into the Little Calumet River. Very flat landscape throughout the entire Sag Valley. These buildings in the distance are along Vermont Avenue. And of course, this is the Little Calumet River flowing to the east. Just west of Blue Island, there was a manufactured gas plant along the banks of Stony Creek. And of course, we're standing on a railroad bridge when we took this photograph. You'll see how low the land is, often flooded. The new canal is going to be built to the south of this gas plant. And there was a lot of railroad rerouting and bridge building that had to be taken care of, as well as building the canal. Incidentally, these photographs, most of the photographs you'll see are from the archives of the Water Reclamation District. And the other photographs, when I show them, I'll give credit. The western 2.5 miles of the Cal-Sag Channel had to be excavated in rock. This was the good old limestone, same as the excavation of the Sanitary and Ship Canal, and the same methods were used. I would cut the vertical wall first, and then use dynamite to blast out the rock, and load it on rail cars and haul it away. Not very far. They would have huge spoil piles as near as they could, although through the Sag Valley with all the marshes, stable land for stockpiling spoil was not easy to find. The western end of the Cal-Sag Channel connects with the Sanitary and Ship Canal, and this was tricky to make this connection. They left the wall of the Sanitary and Ship Canal in place and built the walls and did the rock excavation for the channel in the dry. And then when all of that work was finished, they removed the wall and this dike that was a levee to hold the Sanitary and Ship Canal in place. And once that was flooded, then they would have to remove that dike. That's what this drag line is doing in the background. And in the foreground, these workers are constructing a cofferdam that will be used to dewater the area and build a connecting wall between the Sanitary and Ship Canal wall and the new wall of the Cal-Sag Channel. The middle 11 miles of this channel were through the marsh. And here you see these marshes. We're looking from the Wabash Railroad to the east. And how to deal with this wet, muddy, marshy ground? Well, they dredged it, hydraulically dredged it. They brought in a dredge, and they would suck up the soft materials and pump them. You see over here in the right rear is a large spoil area, which was all this hydraulic fill. And then in the distance, they could bring in the drag lines and excavate the earth. And sometimes they hit some rock, which had to be removed. but mostly it was all through soft, wet clay underneath the marsh. After excavating the channel, they had to line the channel banks with hand-placed rock riprap. This was done in order to stabilize the slopes and also to retard any erosion from fast-moving water. Some areas, despite the riprap, did fail, and you see here different colored rock where they had to repair a failed side slope. The eastern 2.5 miles went through the city of Blue Island and on over to the Little Calumet River. And through the city, working conditions were very limited. And you've seen here, there are buildings to the north in Blue Island, and there's buildings to the south also. In the background is the gas plant. The channel is coming right down through this area. Here they're excavating the clay, loading it on rail cars to be hauled to spoil areas. And then they built the channel through concrete walls. Two walls, 60 feet apart. And of course, the walls were there so that they had a minimum of land purchases as you went through the city of Blue Island. But also with the soft, wet clay soils, the walls help stabilize as opposed to the trapezoidal channel to the west. Here's part of the gas plant over on the left. And in the background, of course, the buildings in Blue Island. Now this railroad in the bottom was for the contractor. He would haul his materials from a central construction yard to wherever they were building the wall. And here they have this false work and form work to build the concrete wall. At the east end, as we mentioned earlier, there's the Blue Island Lock, and here is the inside of the lock chamber, looking from the bottom of the chamber. This wooden false work here is a derrick for constructing the two sections recessed into the walls in these two locations. And of course, there's another set of gates at the other end of the lock chamber. And at the far east end, they had to connect to the Little Calumet River. To do that, they first built this levee to keep the river from flowing into the construction area. And here you see they're building one north wall that has a return into the higher ground. And in the background, the south wall will do the same. And in the background is where they're constructing the Blue Island Lock. And this area over here is what is now called Phase Point, for any of you that are familiar with the Blue Island area. All right. This was the new Wabash Railroad. We saw the Wabash Railroad down on the lower alignment before, but in constructing the new bridge, the railroad decided they wanted to raise the grade and straighten the alignment directly across the valley. And that was done so here. The Sanitary District paid for the bridge. The railroad paid for the raised embankments on each side. The channel is not yet here, but it would go right into this middle span under the bridge. Another bridge building was Western Avenue in Blue Island. Here is Western Avenue coming down from the north, and it did a little dog leg across what was then Stony Creek and went under the Rock Island Railroad. We're standing on the Rock Island embankment. To build this new bridge, they built a diversion around the construction site so Western Avenue traffic could be continuous. Meanwhile, they built this bridge. Here we have one main center girder with two outline side girders. And this bridge had trolley tracks on it, as well as roadway, and then sidewalks on each side of the outer girders. And Stony Creek was kept flowing out. All this was going on under the bridges and under the railroad. Eventually, the creek had to be rerouted when they excavated the channel. And then looking from the Western Avenue Bridge to the east, we see the new bridge for the Rock Island Railroad. Here, the piers are founded on the two walls that are 60 feet apart. And here's the contractor's construction railroad that a gap was left in the wall for that to be usable. Bridges to the west of Blue Island along the country roads didn't have any sidewalks. They were just a roadway to cross the canal. And this is a typical bridge. There was a truss bridge. And this was Piper Road, which became Ridgeland Avenue. And of course, the 5-mile-an-hour speed limit. Can you imagine that on bridges today? Of course, nobody was there to enforce the speed limit, so who knows what speed the traffic went on. Anyway, in addition to building the channel, the sanitary district had to improve the Little Calumet River east of the channel. And it just so happens that while this work was being done in the 1920s, the Illinois Central Railroad decided to build a new bridge where it crosses the Little Calumet River. So here we are looking west along the Little Calumet River. The river goes under the bridge and then does a turn to the right and up around Acme Bend. So this was done at the same time. And while that was going on, the sanitary district was dredging the Little Calumet River 7 miles from the east end of the Calumet-Sag Channel all the way over to Lake Calumet. The dredgings, again, were done by hydraulic means, and the spoil was pumped to the spoil areas on the side. Now, at about this time, the new Calumet-Sag Channel created a more direct link between the Sanitary and Ship Canal and Calumet Harbor. And industries wanted to use this channel for navigation, but it was only 60 feet wide, and that posed a problem. The federal government became interested. The Corps of Engineers had more authority now under the Rivers and Harbors Acts. And it was about this time that they began to plan to widen the Calumet-Sag Channel and the river to the east. However, the Depression set in the 30s, and then the World War II in the 40s, there was no work done, except in the early 1930s, a new channel was dug for the Calumet River south of 130th Street. Here's 130th Street, here's Torrance Avenue. You notice Torrance Avenue at the time had 2 bridges, one over the Calumet River and another one over the Little Calumet River. Well, the feds rerouted the channel in a straight line and were able to abandon the old channel, thus creating what is now the Little Calumet River and the Grand Calumet River and this new channel. And incidentally, this new channel became the place where they built a new lock, which we'll see later. So this was a major improvement at the time. Navigation could easily transit through up to Lake Calumet rather than have go this roundabout way under 2 bridges. And then after World War II, 1946, Congress authorized the Calumet-Sag Channel to be widened and the building of a new lock. Eventually, money was appropriated and construction began in 1955. The channel was made much wider by moving it, the south bank to the south, and increasing the width 4 times from 60 feet to 225 feet. This is the Wabash Railroad Bridge being rebuilt. The original channel was about this wide here, and now they have a new large truss bridge for a clear span. And of course, this will eventually be removed when the bridge construction is completed. Just to the west, incidentally, this is now the Metra Southwest line. Just to the west of that is Southwest Highway. And when Southwest Highway was built, they anticipated a wider channel, so that bridge was built with a much longer span. And the O'Brien Lock and Dam was built in this new channel that we saw a few pictures earlier. A much larger lock than the Blue Island lock, similar design with sector gates at either end. But this lock was 1,000 feet long and 110 feet wide, much, much larger than the old Blue Island lock. In addition to the lock, we had completed the dam across the river to separate the lakeside from the land side of the canal system. And sluice gates were installed in that dam in order to provide regulation of water flow. Now here, the Corps of Engineers operates the lock and dam, and the Metropolitan Water Reclamation District controls the flow through the sluice gates to maintain proper water management for the canal system. Okay, we got the canal system taken care of. We're going to talk about the sewers. Here's an old Chicago sewers map dated 1908. It shows the city's 95th Street pumping station here, and some sewers that drained into the river from the east side and from the west side. And the dotted line are sewers that were planned to be built by the city as this area north of Lake Calumet developed. West of Lake Calumet, the Pullman area had already been developed, and Roseland was developed, and sewage there was pumped by a local pump station built by the city through through the Indiana Avenue sewer south to the Little Calumet River. Of course, it was a long route. Then the sewage would flow out to the lake. This map also showed the plan to build the channel all the way over to Lake Calumet if the federal government would allow the district to reverse the flow of the Calumet River. But that didn't happen, so the channel ended here in the Little Calumet River. This map also shows another one of those lakes that has been eliminated, Hyde Lake. It wasn't even there in 1908, but apparently that was on this old map. And it also shows the Hedgewish pumping, the Hedgewish neighborhood of far south Chicago. It had its own little sewer system and a pumping station which pumped directly into the Calumet River. And that kept pumping until the intercepting sewer system was built. So the district decided to intercept all the sewage in these sewers by building new sewers along the river and to convey it from the new pumping station here across the north end of Lake Calumet and down Indiana Avenue and other avenues into another pumping station and the treatment plant, which was located southwest of Lake Calumet. And this was the new 95th Street pumping station. The old station was located just to the left of this picture. Of course, when this was built, there was no Chicago Skyway, but when they needed to build the Skyway, they ran it right above the station. That's what you see up above the pumping station. So this pumping station collected sewage from on both sides of the river and pumped it away from the lakefront. And fast forward to what we have today, draining the entire south area is an intercepting sewer network like this. And we'll go back to 95th Street now, the new pumping station with its connecting sewers on both the east and the west sides of the Calumet River, flowing north and then the south along what is now King Drive and other streets to the pumping station and the treatment plant. This system is called the South Park Interceptor. It serves mostly the city of Chicago and brings sewage in from the north. The next interceptor built was the Harvey Interceptor coming in from the south suburbs, Harvey, South Holland, Dixmoor, etc. And of course, as that was being done, these areas were developing. This plant had to be expanded. We'll talk about that later. The third system was the Calumet City Interceptor. It came in from the east and it drained Lansing, Burnham, Calumet City, and it picked up the sewage from Hedgewish and brought that into the plants. Later on, that system was extended far south to pick up far south parts of Cook County. And the fourth interceptor is the Blue Island Interceptor coming in from the west. Originally, this just served other parts of Chicago and Evergreen Park and Crestwood, Alsip. But as these suburbs developed after World War II, this system was expanded and extended far out to pick up many southwest suburbs and bring all that sewage over to the Calumet plant for treatment. For instance, Oak Lawn had built its own treatment plant in 1947, and that was taken over in 1955 when that was annexed into the district. Hazelcrest had its own sewage treatment plant. That was taken over in 1961 when the area was annexed into the district. The district even built some small plants in these far out communities for interim service before the intercepting sewer system was extended. Today, drains an area of 305 square miles with a population of a little over 1 million people. Also in the south area, we have a treatment plant on the Sanitary and Ship Canal, the Lamont plant, that's in a small intercepting sewer network serving the far southwest part of Cook County. Many small pumping stations still exist in this southwest area to drain low areas and pick up the sewage and to get it into the gravity system. Now, some relief sewers were built deep into rock eventually when as this area grew and needed more relief capacity, the new sewers were connected to the tunnel system. We'll talk about that later. Then the treatment plant was built. And as I said, construction started in 1919. It was finished in 1922. This was the first mistake they made. They had this outdoor screen chamber and grit chamber. And of course, that doesn't work well in the cold, snowy winter weather we have. All of these facilities are now under roof in heated buildings. But construction of the plant overall was a success. It required huge tankage. They used a process that required huge tankage to treat the sewage, and to construct those, they built these towers that were connected by cables, and these towers were used to lift materials. Materials would be brought to the base of the tower by rail, and then concrete would be mixed, hauled up to the tower, and then distributed out over to the construction area through these tubes and pipelines, and to build this large tankage. A process was used called Imhoff tanks, and it required a lot of tanks covering a large area. You see here the finished product. This process has 2 tanks, the Imhoff process. The upper tank is for the sewage to settle out its solid material, and then their lower tank collects that solid material, and it sits there and digests anaerobically over a period of time. So you have treated effluent, partially treated effluent from this Imhoff process, and you have sludge from the lower compartment. And this piping system is what sucks up the sludge. And where does it go? We'll talk about that in a minute, but the upper tank effluent has to be treated further, and a system called trickling filters was built where the effluent is sprayed over a bed of rocks, a deep bed, like 15 feet of rocks, and this develops a biological slime on the rocks that treats the sewage. And then the sewage is passed through these final settling tanks for polishing before it is discharged to the Calumet-Sag Channel. Now in the foreground, we see what looks like farm plots. What are they for? Well, that's to deal with the sludge. After the sludge was drawn off the bottom of the lower compartment of the Imhoff tank, it was spread out on these sand drying beds. And it was allowed to dry for a few months. And then when it was dry, it was scooped off and hauled away to a dump. Now, it turned out that this was a very labor-intensive practice, so they began to experiment with mechanical devices. And this was a homemade digger that would remove that dried sludge and loaded into the cars. In the background, we've seen this structure. It had no part of the treatment plant. It was a reinforced concrete grain elevator along the Michigan Central Railroad, which preceded the plant, but it survived a long time. It was torn down in the 1980s. There were several experiments conducted at the treatment plant. Part of the one corner of the Imhoff tankage area was converted into a new type of process called activated sludge. And so this operating gallery was built for piping and valving, and to the right of that are the aeration tanks where air is mixed with the sewage, and then in the on this side we have final settling tanks. So a lot of experiments were conducted on this activated sludge process, and eventually it was adopted as the process for all of the district's treatment plants. In fact, it's the process used by most treatment plants in the nation. Another building there was the machinery building, and in the machinery building they were experimenting with different ways of drying that sludge, and they installed these rotary drum vacuum filters. This was a drum that would rotate, and on the drum was a blanket type material, a fibrous mat, and of course they would put a drum under a vacuum. Over in this side was a trough where the sludge from the Imhoff lower compartment would flow into, and then as the drum turned, it would pick up a layer of that sludge, and by sucking the water out, by the time you got over to this side, it would be more like a cake, and you would scrape it off the belt with this long knife and into this trough, and then that would be hauled away by some mechanical means. The sludge was used at the Calumet plant in those farm fields with various types of crops, various loading rates, to see what beneficial use could be made of this dried sludge. So this was the first research that was done by the district on the use of what is now called biosolids. So by now you've heard me use the term first many times. So the Calumet plant was really one of the originators and initiators of many technologies used by the Water Reclamation District. Today, this is an aerial view of the Calumet plant looking from the south to the north. You see the downtown buildings in the distance. The original plant was built right along in this area, and that was 1936. That was a new plant was built using the activated sludge process. Here are the aeration tanks and the final settling tanks, the pumping station over here. These are a series of new preliminary settling tanks, and the grit building is in this location. These are abandoned tanks and so forth. This is the new main pumping station at the plant, and another pumping station. This is for the deep tunnel. We'll talk about that later. Now, as part of the district's stormwater management responsibilities, they had to develop watershed plans, and one of the watersheds nearby is the Little Calumet River watershed, containing many streams that flow beginning in Will County through Cook County and up into the Little Calumet River. We have one area is called the Calumet Union Drainage District, this area in here, and then you have Natalie Creek, Midlothian Creek, Cherry Creek. Anybody who's a resident of South Cook County knows about these creeks. Now, I mentioned earlier that Hart Ditch cutting through the beach ridge. Well, this is part of the watershed today because of that construction, because this causes the flow to go west into Illinois. And this area was Katy Marsh. It extended over into Illinois, and it was a huge marsh. And Mr. Hart in the 1880s owned some of the property here, and he wanted to improve the property for agricultural purposes. So he started to dig a ditch, and Plum Creek, which starts in Will County and flows over into Indiana, emptied into the marsh. And so he started digging this ditch across the marsh and eventually cut through the ridge and diverted that, draining the whole marsh. Today, this is all part of the watershed that is diverted from Lake Michigan as part of the lake diversion. In the Little Calumet River watershed, many flood control reservoirs have been built by the Water Reclamation District. This is the Woodland Reservoir located in Linwood on the Lincoln-Lansing Drainage Ditch. It went into service in 1988, has a capacity of 350 million gallons. It's a huge reservoir. It has 3 open ponds that are interconnected. This is the spillway coming in from the Lincoln-Lansing Drainage Ditch, and this protects the downstream villages of Linwood and Lansing from flooding that would otherwise occur. The Lincoln-Lansing Drainage Ditch is also the name of a drainage district, which still exists in the area. It's an old agricultural drainage district that really still has a purpose, but they have very little resources, and any of their flood control functions can be performed by the Water Reclamation District. The Calumet area also has its own deep tunnel system. You see here a network of tunnels. The Calumet pumping station, the deep tunnel pumping station that I pointed out in the aerial photograph is located right here. And this is on a short north leg of the tunnel system. The tunnel system is centered right at this point in Dolton, Illinois. And these tunnels spoke out like spokes on a wheel, with only 4 spokes here. Whoops. So it's more of a radial pattern. If you remember my earlier talks, the mainstream pumping tunnel from Chicago and the Des Plaines River Tunnel are these long, narrow tunnels. But in this Calumet area, we're more of a radial system. And there's a benefit to that in that we don't have some of the geysering phenomena that we've experienced in the long tunnels up in Chicago and along the Des Plaines River. Well, here you have at the south end of this Indiana Avenue leg, you have the Thornton Reservoir. This is the storage component for the system that holds all of the overflow until it can be drained back through the treatment plant for complete treatment. And then one branch of the tunnel goes over and serves the Burnham and Hedgewish and the Calumet City area. Another goes up along Torrance Avenue and to serve the areas along the lakefront, the 95th Street pumping station. And then you have 2 branches that go along the Little Calumet River, picking up sewer overflows along there, and the Cal-Sag branch, which flows over to Crawford Avenue, and then they tunnel under Crawford Avenue, picking up many combined sewers in the south side of Chicago. And then, of course, that overflow is stored in the Thornton Reservoir. You see here looking south. This is the toll road, Tri-State Toll Road, crossing the Thornton Quarry. The Water Reclamation District bought the north lobe of the quarry and had it deepened to provide the necessary storage of almost 8 billion gallons. This reservoir not only holds combined sewer overflow from a large area of combined sewers, about 30 square miles in the south side and of the city and the south suburbs, but also it diverts floodwater off of Thorn Creek to the east of this site. So it can serve both purposes, and flood and pollution control in the south area. And I mentioned the lake diversion matter earlier. I devote the last chapter in the book to the subject of lake diversion and the litigation which has occurred over this matter, going all the way back to the first litigation filed by the city of St. Louis and the state of Missouri. Of course, they wanted to stop the operation of the Sanitary and Ship Canal. their efforts were to no avail. The court found in favor of Chicago because St. Louis was not treating their sewage either. So anyway, but that started a long line of litigation over the diversion water from Lake Michigan, and that was finally settled by the Supreme Court in the 1930 decree, which allowed Illinois to divert 2.1 billion gallons of water from Lake Michigan a day. Now, that's not the number that's in the decree, but that's a number that I use gallons because we all know what a gallon is. And the number is not an absolute average. It's a 40-year average, running average, and any one year it can be 10% more or 10% less, whatever. But it includes the runoff from this 673 square mile area that formerly flowed into Lake Michigan through the Chicago and the Calumet rivers. And so about, on average, 25% of this 2.1 billion gallons is the amount of water that would have flowed into the lake from this area. So what is the other 75% of this? So used for municipal water supply. Most of it is used by Chicago and the many suburbs in the Chicago area. And that water is allocated by the state of Illinois. Each user of Lake Michigan water has to get an allocation order from the state. And all of that diversion is reported to the state and eventually to the information to the Corps of Engineers. And they are responsible for accounting and reporting to the court. Part of the lake diversion is also taken by the Water Reclamation District as direct flow from the lake through the Chicago River, through the North Shore Channel, and through the Calumet River, where they have regulating works on each of these three intake points. And as of the latest year approved by the Corps of Engineers for accounting, Illinois was diverting a little less than that 2 billion gallons of flow. So we're managing the resource very well, and it will make the lake, it'll protect the quality of Lake Michigan for many, 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 many decades to come, and make it a very sustainable source of water for Chicago and Northeast Illinois. I think that is the end of my slides. It is, and just to remember, Calumet was the first. I've mentioned many firsts, and the forever is my belief that it should always be Calumet. The elected commissioners at the Water Reclamation District have the authority to change the name of plants, and they have changed the names of several plants and facilities in the past. But the name Calumet goes with the area. It preceded the European exploration and settlement of the area, and it should always be called the Calumet Plant. And with that, thank you for your attention. I'd be happy to answer any questions. I'll turn it back over to you, Jim.
Thank you very much, Dick. That was great as always. Really appreciate it. You know, if they were to change the name of that Calumet plant, the Richard Lanyon plant wouldn't be a bad choice.
No.
But thank you very much. I got one quick question I'll start with. You talked about very early on the Calumet River sort of changing course. Instead of flowing out into the river at Miller in Indiana, that started flowing out through the Calumet Harbor Ship Canal. What does the Calumet Harbor Ship Canal do now in Indiana? Does it dump out into the lake at all?
The Indiana Harbor Ship Canal? Yeah. Yes, it flows right into Lake Michigan.
Well, that's wonderful, because I've sure seen what it flows through, and that's not good, because that's the water I drink down here in Indiana.
Well, that's correct. And you know, the Gary Works and other steel mills in the area used, particularly the Gary Works, they would pump their water from the lake for cooling and industrial processing, and they would discharge it into the Grand Calumet River. So the Grand Calumet River would then flow back out to the lake through the Indiana Harbor Ship Canal.
I've seen quite a few of our canals around the industry down here. It's wonderful having all the jobs that come with our industry down here, but some of those canals are kind of scary places.
Well, they're getting better.
Yeah, the local dive teams that do all the fire department rescue stuff. We start with hazmat training before we do any other training down here. Anyone else that would like to unmute themselves and ask a question at this time, you're welcome to. I'm checking our notes here. I'll ask one other question while we're waiting for someone else. The canal didn't go straight through Lake Calumet or the channel or the Cal-Sag Channel. It didn't actually use Lake Calumet. Why was it decided not to make use of going through the lake or to bypass it?
Well, in 1910, the Sanitary District applied to the Corps of Engineers for a permit to build the Calumet-Sag Channel, and they wanted to divert up to 4,000 cubic feet per second additional diversion from Lake Michigan. And the Corps of Engineers said, no, you can't do that. You can't build a big channel to divert that much water. We'll give you a permit for a small channel, but we don't want you to build a big channel. And then, so the district said, we don't need to extend this all the way over to Lake Calumet if they're only going to let us build a small channel. So that's why it was, the eastern end was terminated at the Little Calumet River near Blue Island.
All right, thanks.
Okay, so if that had run into the into Lake Calumet, that would have, well, this was before the O'Brien Locks was built in, or
Oh,
do I
yes.
have this right?
Yeah, much
Okay.
before then.
Okay, so
There would have been some sort of a control structure somewhere along that new channel anyway.
okay,
The idea was to, take it directly to the south end of Lake Calumet. And, the Little Calumet River kind of wiggles around and meanders between Blue Island and Lake Calumet. So
it does, yeah.
just cut it short.
Okay, now the route of the original Little Calumet, is that what runs past Phase Point?
I'm sorry, what?
The original Little Calumet River, from where the Cal-Sag takes off, that turns into a little creek. Is that what runs past Phase Point there?
I'm not quite getting the point of the question.
Okay, the Little Calumet was dug out and it was joined with the Cal-Sag, which is that great big channel all the way out there. But the course of the original Little Calumet doubles back to Indiana, right?
Oh, yes.
And
Yeah,
that turns into, it's virtually just a little creek by that time.
Yeah, before the pale faces came, the Little Calumet River flowed west over to Blue Island, and then Blue Island was this big hunk of blue clay, and it turned around and flowed back east. And because the way the Lake Michigan, kept bringing sand down the lake shore and kept moving the mouth of the river farther east, and so when the settlement occurred, the mouth of the river was over by Miller, Indiana.
Okay. Well, thank you. This is really fascinating to hear. I used to work at Riverdale. I used to run Riverdale Marina, the old triplex. So that was all my territory down there.
Uh-huh. All right, well.
One thing I didn't mention during the introduction is that with this being the fourth book, he's up to 1,640 pages in his 4 books. That's a pretty busy retirement you've had.
Well, I never added them up. Thank you.
I was flipping through all of them before the program tonight and started counting. Two of them are the same number of pages at 426. One was 422, the other 366. Did you mention tonight the online sources for the photos?
The photographs?
Yeah.
No, I didn't mention that, but there are, on the first slide, there was a couple numbers there. There's about 90 photographs in the print book. But in picking out those 90, I had gone through several hundred, and I decided those were worth viewing. So they're on a website that is mentioned in the front part of the book where it talks about the photographs. And you can go to that website and spend your whole day going through 560 or so photographs of the Calumet area. And then all of the photographs for the other books are also on the website.
Yeah, many of us really appreciate you putting all those up there. It really is an incredible resource, and they're phenomenal photos. Being big glass plates, they're high quality and really interesting. How many total are in the collection?
Yeah, well, there's like, I don't know, 15 or 20,000. Last March, up until last March, I was spending a day a week at the old district office on a project to go through all of these and, create an archive and improve the scanning of some of them. And then with the pandemic, they shut the office, and so my little project got put on hold. But I hope to get back to it. It is a wonderful resource, and the district puts a photograph up on the photograph of the week up on their Facebook page or something, and they often find a photograph and they say, "What is this thing?" And they send me an email and what is this photograph? So the other day I got an email asking about this photograph, and the photograph was of somebody blowing up a small stream with dynamite. And what were they doing? Well, this was in the 1920s, before we had a mosquito abatement district. And there were a lot of complaints about mosquito breeding in these creeks in Cook County that would get stagnant. And so besides using oil and various insecticides of the day, somebody had the idea to dynamite the streams to disturb the wetlands along the streams where the mosquitoes would breed, thinking that if you dynamited all this mud, you kill off the mosquitoes or disturb their breeding grounds. Yeah, that's what they were doing back then in the 20s.
Hey, Dick, may I ask a question?
Go ahead.
Hello? Yeah, hi, thank you. Chris Scanlon here speaking. I see my picture's not up there, but in any event, so I have some relatives who live north of Ridge and east of Calumet Road. I guess that's in Indiana. And that whole area was flooded pretty badly about 10 years ago or so. Then they built some dikes along that river. Is that the Little Calumet? Is the Water Reclamation District involved in any of that work in the past over there, or is that something strictly for Indiana? Is there cooperation between the districts there?
Well, yes and no. The no part is that all of the work along the Little Calumet River on the Indiana side was done by the Corps of Engineers, and they built levees along the Little Calumet River to confine the flooding. That work was not carried into Illinois. Illinois decided not to be a sponsor for that work. Instead, the Water Reclamation District was building reservoirs and decided, not to build levees along the river channels.
Okay, thanks. So I always wonder when I see a levee being built that at some point the levee ends and either it's going to go to Lake Michigan or it's going to go into a reservoir. I just don't know where that ends down there. I haven't followed it out that carefully, but I was curious if that the reason the district doesn't do levees, or do you prefer just the reservoir approach for managing that kind of thing?
Well, I think part of the reason is that the channel through the Indiana towns and villages, very flat, and there's been a lot of development, and you know, they've really occupied a lot of the floodplain areas. On the Illinois side, a lot of that river channel riparian land was bought up by the Forest Preserve District years and years ago, and there wasn't the serious amounts of flood damage right along the river channel. Where there was flood damage in communities, that's why the Water Reclamation District would build reservoirs to contain the floodwaters. And that was just a different philosophy of how to manage the stormwater.
Good, thank you. Appreciate your answer. Thanks a lot. Great presentation.
Thank you.
Boy, Chris, I hope your parents' house wasn't directly in that flood. That was, I think, 2008 when that happened.
It was my cousin's house, and it absolutely was. Yeah, it was the water was like halfway up the wall. Yeah, it was amazing. It was real
September
catastrophic.
2008.
Yeah.
Yeah.
I'd wake up every morning to hearing the news helicopters showing the highway still being flooded, and it was quite a time. I wanted to make a big sign to go up on my roof saying send FEMA trailers, because this was shortly after all the FEMA trailer stuff down after Katrina.
Yeah, so you know where I'm talking about.
Yeah.
In that neighborhood. Yeah.
I live just off Ridge Road down that area.
Yeah, out there behind that hospital and all. Right.
Right.
Yeah.
Would anybody else? Bill Darrah looks like he's been itching to ask something.
Yeah, I was wondering if there are any parts of Cook County that are not hooked up to the central metropolitan wastewater treatment system.
Yes, there are. One of the things I talked about in this book was the territorial expansion. Up until the end of World War II, the Water Reclamation District didn't cover all of Cook County. In fact, they covered very little, not very little of it, but only about 400 and some odd square miles. You know, the city of Chicago, the north suburbs along the Des Plaines River, and so forth. The southwest suburbs were not in the district, nor were the northwest suburbs. 1955, the state passed an authorization to annex the suburban areas that would double the size of the district. And that referendum was approved in 1956 and basically expanded the district to the size it is today. But the areas of the Cook County that are not in the district, and I qualify that according to their wastewater authority and taxing authority, are Barrington Township in the far northwest corner, and parts of Bloom Township in the far south part of Cook County. Barrington Township is very low density, a lot of Forest Preserve District property, a lot of large land holding sites. And in South Cook County, we have another sanitary district called the Thorn Creek Basin Water Reclamation District. That's been in existence going back early part of the 20th century. Now, I said that was the wastewater authority. In 2004, when the state authorized the district to be the stormwater management authority for Cook County, it was included the whole county. So these areas up in Barrington and in South Bloom are within the district's stormwater management authority, but that's not within the taxing authority. So it's a little it's a little bit of governmental logic there. I don't know why.
So they won't, they don't vote for the board then?
Pardon?
They're in the stormwater district, but they don't vote for the board members.
Yeah, you don't vote. The voting and the taxing is only limited to the wastewater authority.
So what does the Barrington area do with their wastewater? Do they have a separate system, or is it independent for property owners?
Well, a lot of the property owners have their own water and septic systems up there. But the village of Barrington itself has its own little treatment plant. And there may be some others like that. Some of that area drains to the Fox River, et cetera.
Okay, thank you.
Welcome.
We've got one question in the chat for you. It says, with all the sewer improvements on the Cal-Sag, why is it still so polluted?
What do you mean it's still polluted?
Well, maybe it's not as polluted as we all think.
Yeah. Well, you know, I've been around too long. I can remember when it was pretty raunchy after a storm, but you don't see that anymore. It's much better. For the Calumet area, the tunnel system is very effective. And of course, the Thornton Reservoir is complete. It's been in operation for about 5 or 6 years. So it's doing its job. And I mean, if there are pollution problems, they need to be identified and resolved. But for the most part, you know, sewage isn't going into the waterways anymore.
Anyone else want to jump in before we wrap
How
up?
about, one real quick, what's the best way to get your books there, Dick?
Pardon?
If we want to get some copies of your books, what's the preferred way?
To obtain the book?
Yes.
Well, you can find them on Amazon, of course.
Okay. And
the website of my publisher is, you can either find it through Lake Claremont Press, or their longer name is everythinggoesmedia.com.
Okay.
We have the, in the chat box, there's links to
Yeah, there's
getting
a
the books.
link in the,
Excellent. Okay. Thank you.
Hey, Dick, another question if you don't mind.
Google, you know, just try the good old Google search. Sorry, Chris. Go
Oh,
ahead.
that's all right. You're the guy here. But to the other gentleman's question about why is it so polluted, I think just from talking to people in general, I'm not an expert on this, but I think people often confuse pollution or the sewage with just residual mud and muck in a lot of these streams and rivers. I know I do a lot of canoeing, and that's, I find that, you know, sometimes they're very muddy, but they're not necessarily, it's not sewage you're dealing with. But in your opinion, is there a long-term perspective on, you know, when a lot of this muck that's been in these rivers for ages will, you know, slowly, you know, be cleaned up in a sense? So these things are, I know they're not going to be pristine, but over time, perhaps they're going to get less what people generally consider polluted, or do you have any thoughts on that? Or is it the district? I don't suspect you do kind of remediation on river bottoms and things as part of the district.
Well, like I said before, you know, if there's a site-specific problem with stream quality, you bring that to the attention of the district, and you know, they'll look into it. They have a.
Yeah, I'm not thinking of site-specific. I think there's a really good, I believe you've done, and you know, has done a great job of controlling that. But I'm just wondering over long term, do you have any thoughts about what it would take for these rivers to, you know, become more, you know, the sediment on the bottom of these rivers eventually will clean itself, you know, with flow? Do you have any idea? Is that really realistic to think that's going to happen?
Well, I think in your deeper channels, the sediment is really a legacy issue that's been there for many, many years. And it's probably best to be left alone rather than stir it up and try to move it somewhere. But in your shallow channels, it's, you know, where you have good reaeration and of flow, you know, pollution, the stream has a certain assimilative capacity for pollution that could cause be natural sources, but any unnatural sources, you bring them to the attention of the district and they have enforcement authority. Either they or the going with the state of Illinois could address local issues.
Great. Yeah. Thanks, Dick. Appreciate your response. Again, thank you for the presentation.
There's non-point, you know, source material. There's kind of just general stuff that goes in the rivers that has nothing to do with the wastewater.
Yeah, there's the non-point sources are in some cases sources of pollution. But you know, now all stormwater systems have to be permitted by the state, and those permit holders have to have pollution prevention plans so that non-point source pollution is addressed. Currently, there's a big issue about chlorides and the use of de-icing salts. There's attempts to reduce the discharge
Salt
of
water.
chlorides from that, you know, program to de-ice our streets. And another issue is nutrients, you know, runoff from farm fields or properties where they use fertilizers and soil conditioners that might increase the nutrient loadings.
Dick, talking about removing contaminated sediments, the Corps of Engineers has a number of projects. You mentioned Indiana Harbor, the contaminated sediments at the bottom of Indiana Harbor. The Corps is doing a project of dredging that material, putting it on land, drying it out, and treating the effluent. So they've done that. They did a project, well, Waukegan Harbor. And of course, Bubbly Creek is another project that the Corps is involved with. So there's a number of projects where they're treating contaminated sediments.
Right.
Most notably Indiana Harbor.
Yeah, well, the Corps has done, for instance, you've got the Iroquois Landing confined disposal area where contaminated sediments are confined and won't impact the environment. And then on Bubbly Creek, they're talking about encapsulating the sediments on the bottom in some way. Yet to be demonstrated, but it sounds good anyway.
Well, as long as the
Yeah,
Pershing
the basement.
pumping station is there, can they really do anything?
Well, they have to, I mean, in case of Bubbly Creek, the Racine Avenue pumping station is the savior of 30 square miles of the city's south side. So you can't disturb that operation. When it rains and the south side needs to be drained, you got that station goes into service. And as the Maritime Museum knows only too well, when it happens, you know, there's a chance that you get flooded out because you're sending a tremendous amount of water down that channel. Now, the Corps says that their encapsulation will work. It remains to be seen if that's true. I mean, the district one time put up a floating barrier across Bubbly Creek at 35th Street in the hope of trapping floatables. And the first time the pumps were turned on after a big storm, it just tore the barrier out. And it just
Very good. Well, it's getting close to 8:30. Before we go, I want to give a quick shout out to, I've been looking through the names of all the guests and a lot of you folks I haven't seen in at least a year, but I want to say hi to Dan Corneli. Dan's been involved with the museum and a great friend of the museum going all the way back to the earliest days in the 1980s. And glad to see him and appreciate all of his involvement over the years and hope everything's going great with him in his retirement. Last chance for anyone else to get a question in. Well, Dick, we hope you're able to get back into the office and work more on the photograph collection. You're doing a great service to all of us by making more of those available and taking good care of them. And now that your series of 4 books is completed, is there anything else besides that photo collection that you're focusing your time on?
Oh, I'm busy. I live up in Evanston. I'm busy in civic activities here. We're doing a big update on our stormwater management plan. I'm involved in that. And so, yeah, I keep busy. Lately, I've been doing a lot of snow shoveling.
Evanston's lucky to have you, especially the work you do at the school there with their gardens, and you're certainly a wonderful guy to have around. And we've loved having you come for presentations. And just because you finish your 4th book here, hopefully we'll find a way for you to be involved with this more in the future. And looking forward to when we can all meet at the museum again. This will be a lot more fun when we can do this in person. So
Thank you, Jim.
So thank you very much for coming. Thank you to everyone for coming tonight. Certainly made our first attempt at doing an online program successful, and really looking forward to having many more great programs to come. Last chance for anyone to say anything? All right, well, thank you again for coming. Dick, thank you so much for doing this for you. We really appreciate it. Everybody buy his books. They're really fascinating.
Yeah.
And yeah,
Thank you.
definitely worth getting.
All
Good
right.
night.
Thank you.
Bye.
Okay, good night to everyone.